topic that is forefront for modern technology and innovation. Embedded systems have become the backbone of countless smart solutions in today's world. From intelligent healthcare system and autonomous vehicle to smart home and industrial automation. And with this integration of artificial intelligence, the systems are no longer just reactive but increasingly becoming intelligent, adaptive, and autonomous. So I welcome Dr. Mahantesh R. Chowdhury, sir, for today's session.
Thank you.
Dr. Mantesh R. Chowdhury received bachelor degree in electronics and communication from VTU Belagaum, holds a master degree in digital signal processing with distinction from Sri Bhagwan Mahavir Jain College, Bengaluru, completed his research-based project work in RVCE, Bengaluru, pursued his PhD in image processing in the year of 2016. He worked as a test engineer, worked as an assistant professor in engineering Department of Electronics and Communication in BCET, Puttur. And he also worked in ACS College of Engineering, Bengaluru. Now associate professor in Vivekananda College of Engineering and Technology, Puttur. He has handled various portfolio with key achievements in the area of digital signal processing, embedded system, and VLSI. He owns startup Mark Edu Tech Solution, actively involved in tech training, industrial automation assistance, startup assistance, etc. So I welcome you, sir. And once again, I welcome everyone for this session. Have a great day.
Thank you very much.
Thank you, sir.
Yes, good afternoon, dear students. Myself, as they told, Mahantesh R. Chowdhury. So, actively involved with respect to market tech. Mainly, we are going ahead with respect to industrial boards, industrial as well as automation boards. And along with that, a few PCB designs we are just capturing views with actually. So which makes a low cost if I consider with the area wise, if we consider it like that. There are few constraints where we are going to concentrate. And even we used to provide training and internships with respect to that. So if you are interested, just let me know later. Today's topic, innovation trends in embedded system. As we know, embedded system, if I tell, so everyone will look at, okay, so there should be what? As of now, if we consider trends, today's trend, so we are having prescribed units for that. So everything embedded with respect to software or else electronic components, what we used to deal with, they are going to be embedded with respect to software for a particular application. So if I consider with respect to this, so go back with respect to what slides I'm showing here. So just go ahead with respect to brief as a basic. So you need to know few things with respect to. So then I will describe innovative trends, what are happening, and what actually features we are going to get with respect to this embedded system. So as we know, introduction with respect to embedded system, if I consider embedded system is nothing but electronics or electromechanical, if I consider. So system which is designed to perform so specific application based microcontroller, when we used to call. So as of now, modern embedded system that used to differ as of now if we consider with respect to embedded system. But so this basic embedded system performs specific function and is a combination of both hardware as well as a software. And examples if I consider, so electronic toys if you consider, mobile handsets if you consider, washing machines, air conditioners, automotive control units if we consider. So almost they are with respect to specific function, and they are combination of both hardware as well as a software. So as of now, a few more examples. So even we can deal with what presently we are going with respect to embedded system units. So these systems are what? Unique in character and behavior with specialized hardware as well as what? As well as a software. So come across embedded system. So if I consider embedded system, how that used to differ with respect to general purpose system. So what is general purpose and what is embedded system? So if I consider with respect to general purpose system, so in general purpose system, a system which is a combination of a generic hardware and a general purpose operating systems for what? Executing a variety of applications. But what happens if I consider with respect to embedded? So you can just analyze there itself, a specific purpose hardware. And what? Along with that, operating system. So embedded operating system for executing a specific set of applications. So if I come across with respect to a few more, whatever details, how they have just mentioned with respect to difference between general purpose as well as embedded system. So in general purpose, again contains a general purpose operating system. We used to call it as a GPOS, but in embedded, may or may not contain operating system for what functioning, because embedded with respect to OS that used to execute a specific set of applications. So that is a major intention with respect to embedded. And general purpose, if I consider, applications are what? Alterable, so by user. But if I come across with respect to embedded, so they are nothing but what? The firmware of embedded system is a pre-programmed and is not alterable by end user. So again, if I go back with respect to few more differences, performance is a key deciding factor on the selection of what system. So always faster is the better, we used to call it with respect to general purpose system. But in the embedded system, application specific requirements so are key deciding factors. So like performance wise, if we consider, power requirements, if I consider, memory usage, if I consider, so they used to give specific requirements with respect to embedded system. So again, few more difference if I consider with respect to less or not at all tailored with towards reducing operating power requirements, but highly tend to take what advantage of power saving modes supported by hardware and operating system. So general purpose system, if I consider, response requirements are not time critical, but what happens if I consider with respect to response time requirements are highly critical. So that is a major one more difference. So and consider with respect to general purpose, so need not be deterministic if I consider with respect to execution behavior. So, but in embedded system, execution behavior is deterministic for a certain type of embedded system. So like a hard real-time systems, if I consider, so they used to play important role. So these are nothing but what? Embedded system, what actually they used to do. Okay, software you are having along with the hardware for a specific set of application. So that is nothing but embedded system. How that used to differ with general purpose system if I consider. So come back with respect to embedded system. So first recognized modern embedded system by AGC, so Apollo Guidance Computer. Then first mass produced embedded system if I consider Alternatives Guidance Computer, we used to call it as. And we are having few classifications with respect to embedded system based on generation if I consider, based on complexity and performance requirement if we consider, also deterministic behavior if we consider, also triggering wise if I consider. So we are having few more classifications with respect to come across these. So what happens if I consider with respect to generation? So the early embedded system if I consider, first generation, what they used to call it as. So the early embedded system built around 8-bit microprocessor like 8085, also Z80, and 4-bit microcontrollers. As of now, what we are seeing, so if we consider with respect to today's almost SoC system on chip they came out. If I consider with respect to our mobile phone, so mobile phone, they are manufacturing with respect to SoC system on chip more than a processor. So they are built with respect to 5 nanometer technology. Today's technology, if I consider what mobile phones we are getting, so they are nothing but more than. So 5 nanometer technology with respect to that range we are getting with respect to just nanometer range if we consider lesser than that. So just think of where embedded system that is playing a role. Then come across the second generation embedded system built around a 16-bit microprocessor. So first generation is 8-bit microprocessor, second 16-bit and 8 or 16-bit microcontroller, combination of those, or following first generation with respect to embedded that happened with respect to second generation. Then the third, if I consider embedded system built around high performance, in the sense, if I just come across with the first and second, so 8 and 16, if you used to come across 16 32-bit microprocessors and controllers you are getting here, and application specific instruction set processors like as we know, DSP, digital signal processors, and application-specific integrated circuits, we used to call it as ASICs, we used to call it as no. So they came with respect to third generation. Then similarly, if I consider with respect to fourth, as of now, what we are dealing with, so they all are okay. Mobile phone, if we consider more than whatever the systems they are coming out with, so they all are SoC, system on chip. So embedded system built around system on chips. So reconfigurable processors and multi-core processors there. So how they used to differ from first and second. So if I consider processors, here itself we can just divide them, multi-core processors. So they used to do multi-core processors are there, multiple operations they used to perform like that. So embedded system classification based on generation. So second, whatever classifications they have just mentioned, so that is nothing but classification based on complexity and performance wise. So as we know, where you are giving importance today. So if I just go back with respect to your old mobile phones, how much weight they are, if I consider with respect to size, how they are, like if I consider old 1100, like okay, so Nokia I'm telling about. Also some other mobile phones we just consider. Where smartphones are not at all there. If I go back with respect to so 10 years back or 15 years back, okay. So how they, if I consider with respect to how they came across complexity and performance-wise, how